So this is the November 2014 paper. So I'll have to write this on here for you all. Maybe try it first, or some of the questions first at least, and then have a look at what I'm saying. So good luck with this paper anyway. So let's begin. I've not really spent too much time on the other videos looking at the formula sheet. I tend to try and know formally by proving them from first principles. This one here is not too bad to prove to yourself why that works. This one can be a bit tricky, but it can easily be done. These ones are quite hard, I have to say, the ones involving the sphere, but so luckily they're given for you. And the cone ones aren't easy either. This quadratic equation, I guess the better you are at your algebra, some of you have probably gone from ax squared plus bx plus c is naught to what you've got here. I've got a video on that if you want to look at it. There's plenty of others on YouTube as well. So you don't just have to learn that, you should be able to prove it. And the more you do it, the more it will stick in your mind. And again, you can prove these ones nicely, and I've got videos on all of these too. So I don't think there's a massive deal here on these formulae. If you just break them down, try and learn as much as you can from first principles. Anyway, let's get on with the paper. So for this question, that's got the ingredients for 10 pancakes, and you want to make 30. How much flour is used? Well, let's have a look. I think this is just a matter of timesing all the ingredients by 3, to be honest. So flour, you would have 3 times 120, which would be 360 grams, because you want to make 30 and you're given the recipe for 10. For the next question, next part, Tara makes some pancakes. She uses 750 ml of milk. Work out how many pancakes she makes. Well, if 300 ml gives you 10 pancakes, then 600 would give you 20. And then if you halved the 300 to give you 150, you'd have to halve the 10 to give you 5. And then 600 and 150 is 750 mils altogether. And then you would have to add 20 and 5 together. So I would give 25 as the answer. So for this question, we're looking at a scatter graph showing the information about 10 pine cones from the same tree, and we're probably going to be asked to comment on the relationship somehow. It says describe the relationship between the length and the width of a pine cone. I would generally anyway just draw a line of best fit personally, so let's try that. And I would get it to be around about there. So you've got, reasonably going through the centre of where the trend is. Hasn't got to be perfectly correct. And then I would say, describe the relationship between the length and the width of a pine cone. I would say it's a strong positive correlation. And I would also say in English, as I said, like a sentence, as the width of the cone increases, so does the length. It's probably better to say, well, I wouldn't say much better, it's It's probably the same really, to say as the length increases, so does the width. But it's an upward trend anyway, and it's a strong positive correlation, as opposed to a weak positive or a weak negative or strong negative. So it says another pine cone from this tree has a length of 8.4 centimetres. So first of all, get your 8.4 ready. So you know this is 8.5 here. So 8.4 is going to be here. So what I would do is, with a ruler, I would draw a dotted line up to your line of best fit, and then read carefully along. You know, I'd go this way generally because it'd be easier to get it right. And I would say that would be 6.2. So I would say estimate the width of this pine cone, and I would say 6.2 centimetres as shown. Okay, do not forget to draw these parts here. Don't just look by eye and then read across, because the examiner cannot tell whether you looked at it or not. You have to show it. So, is there any more on here? Nope. And we'll go on to the next one. For this question, you're asked to work out the value of f when g is -5 and h is 2. So we would have f equals 3 lots of -5 plus 7 lots of 2. And that would be -15 plus 14, which would be -1. So don't forget to show all your workings. Although it's a calculator paper, don't just put things straight into your calculator, because there is like 2 marks up for grabs. So factorise 3x plus 6. Well, that's 3 times x plus 3 times 2. So 3 will be the common factor. So you'd have 3 lots of x plus 2, and then multiply that out to check. So you've got 3x, and 3 times 2 is 6. So there's the answer, 3 lots of x plus 2. Then we've got to expand and then simplify. So we'd have 5y minus 10 plus 2y. Now plus times a minus, that's a minus, so we've got -6. Now we want to simplify. So 5y and 2y, that's 7y. And then -10 with 6 more taken away. Don't get confused thinking a minus and a minus make a plus in this instance, because you've got -10 and you're going back 6 spaces, so you want to be on -16. So you'd have 7y minus 16. The next one, you've got to simplify. M to the power 5 times m to the power 3. Well, m to the power 5, longhand, will be this, times by m to the power 3. So if you think about it, the power here, the index would be 1, or the power would be 1, and you would add those up, so you'd have m to the power 8. In this instance here, if it helps, just write them longhand and then divide it by p squared and then cancel. Doesn't matter which ones you cancel, because you'll be left with p to the power 1s, these are. So you'll have 1, 2, 3, 4. So you've got 4 powers here, so 1, 2, 3, 4. So you've got p to the power 4. That's p times p times p times P. Now, usually this is just here, I'll do a different colour, this is just testing the indices that you should know. If you have a to the n times a to the m, then that's always going to be a to the n plus m. And if you have a to the n divided by a to the m, then you're always going to have a to the n minus m. Okay, so that's testing those two. So in this case, we're asked to reflect shape A in the line y equals x. So it's saying that this is the mirror that we're looking at in this case. So if we pick a point here, then if you go straight to the mirror at right angles, then you've got to be that distance away. So that's going to be that point. This point here, well, it's 1 and a bit away. So if you think about it, there's the little bit and there's the whole one here. So that's going to be that part. So this one's going to correspond to this point. And then this part here, you want to get to the mirror. So you've gone one diagonal and that little part. So there's the little part, and then there's one diagonal here. So there's the other part. So this bit corresponds with this part. And then lastly, we are just 2 diagonals away. So we've got to be 2 diagonals away here. So we can finish the part off. So these are the vertices, or the corners, that we have. And then you join the points up. So these two join here with this one. This one here joins with this one. And then so on until we get all the way round again to here. So that's not easy for some people, but that's the reflection, and this will be the image here. Okay, so just shade that in and make sure it's clear on your diagram. The next part says, describe fully the single transformation that maps triangle B onto triangle C. So a mapping is just like finding a rule which makes something move to another place. So look at it that way. So we want a single transformation, so it's just one thing that happens. And I think if I was doing that, I would just with my finger just move B to C. So when we're looking at movement, we're looking at a translation, and the best way to say that is a vector. So if we look at a point here, how would we move that? Well, we'd go 1, 2, 3, 4 along. So 4 this way, and then we'd go 1 down. But the best way of saying that is to say it in vector form, and that is 4 minus 1. Okay, because if you have a vector, and I'll write this here, x, y, then this number here is the movement on the x. That could be positive or negative depending whether you're going greater from like 0 onwards, like 1, 2, 3, 4, 5 to the right, and if it's negative that means you'd go to the left first. So if you had a vector, say negative 2, 3, and you were starting from an origin here, that means you'd go back 2 first, and then you'd go up 3. Okay, so the values for x and y here can change, but in this case, let's just check if it works. So along 1, 2, 3, 4, down 1, yes, we do get to that corresponding point, and then the last one you can check yourself. So I would say a translation by the vector, and then we've already written that just there. Okay, so that's what I'd say for that question. So there are some green, yellow, blue and red counters in a bag. The table shows the probabilities that a counter taken at random from the bag will be green or yellow or red. And you've got to work out the probability that the counter will be blue. Okay, so what do you think there for this one? Well, it's going to be one of the colours, isn't it? So if you work out the sum of, I put 0.40, it's easy to add, the sum of them here, and then we'd have 10, 6, 7, 8, 0.8, which would have to leave what? Well, it would have to be 0.2 or 0.20. So that's the answer for the first part. And don't forget, this is a calculator paper, so you could probably do much of this on a calculator, but I really do plead with you to show your workings. Don't just leave just an answer there and no workings whatsoever, because if you make a single mistake, you won't get too much, you'll get 0. Mary puts the counter back into the bag. There are 125 counters in the bag. Work out the number of green counters in the bag. Well, the probability of choosing a green counter would be 0.16. So no matter how many counters you chose from the bag, be it 10, 100, million, you would have always 0.16 chance of choosing a green. Now, these are the kind of calculations you can do on the calculator then, but show your working like I said. First thing you could write is 0.16 of 125 and write down your answer. So I'm not just going to use the calculator. I think the answer is 20. That's what my head tells me, but we'll just check it. And let's do it without a calculator. So there are a number of ways here. And I strongly suggest that when you're doing revision, be it a calculator or a non-calculator, that you always try a non-calculator version whenever possible to improve your skills. But obviously when you're in the exam, you may not take that risk. So if we wanted to do 0.16 times 125, so first way without a calculator is you can say that this is, well, 0.16. Well, that's definitely less than a half, and hopefully you're with me that it's less than a quarter. We'll stick it at that, just roughly, and we'll say this is roughly 100. Let's just say to the nearest 100. And a quarter of 100 is 25. Now, with this method, you can just do 16 times 125. You can just do the digits here and the here. So we'll do that. And we'll just do the multiplication grid. And you can do this however you like, because you've probably got your own method. If you haven't, then you can follow some of the videos that I've got on multiplication. So we've got 30 here, 17 and 3 is 20, 8 and 2 is 10, and 1 is 2, and we're looking for the number around 25, so 20 the answer. That's one way of looking at it. The other way is, now this always happens when I do this, let's try and move this here. Let's do 0.16 times 125, and this time let's make it into a fraction. So we've got 16 hundredths of 125. Of is times, and then we can cancel this down to be 8 50ths of 125, cancel it down again to be 4 25ths of 125, and then look, this is the same as doing 4 whole ones of 125 25ths, because when you're multiplying fractions, it doesn't matter which order, so you can swap the numerators and denominators around to help you cancel a bit better. And 25 into 125 is 5, and there you can see 5 fours are 20. So there are numerous ways that you can get to the answer without a calculator, but with, there we go, 20 counters in the bag. These questions can be reasonably scary for people new to the higher paper because they get difficult enough that you can easily make mistakes. So you've got to think now that the cost of the newspaper is €5, and that's how much you'd pay for it in France. In England, however, the cost of the same newspaper is £2.50, and you've got to work out the difference in cost of the newspaper in France and the cost of the newspaper in England. Now, I suggest that you can either do that in euros or in pounds. If you're going to do it in euros, then you'd have to convert £2.50 using this conversion here. Now, £2.50 is going to be 2.5 lots of these, therefore 2.5 lots of these. So simply on the calculator you can do 2.5 times 1.16. Now obviously you could do that on a calculator, but another little thing you can do is you can double this one and halve this one. So what would half of 116 be? It'd be 58, so we'd get 0.58, and then we can double this one and halve this one, and so we'd get 2.9, and that would be 2.9 euros. Now, what's the difference now between 2.9 euros and the €5 that it cost in France? Well, the difference in euros there is 5 minus 2.9, which is 2.1 euros, which seems quite a lot. Now, let's look at the pounds now. Well, we know the newspaper is £2.50, but it's €5, you see. Now this is harder, so if you watch this, £1 is 1.16 euros. So if we divide both sides by 1.16, that will give us what €1 is. So €1 is 1 divided by 1.16, and I'm not going to try that without a calculator, I promise you that, so we don't need to. So we want to just change this into 5 here, this one here. So the way to change that into 5 is not by adding 4. If you think about it, it's as the questions get more complicated, it's less about adding and taking when you're working out difficult problems. It's more about timesing and dividing. I'm not saying that's hard and fast rule, but in this situation we've done division here to get 1. We didn't take away 0.16 from here, did we, to get 1? So think, to get 5 here, we'd have to do the same to both sides, and that's not necessarily adding 4. And a simple thing to remember is if you've got a fraction and you want to make a fraction that's the same as that, you don't go adding 4 to top and bottom, do you? Because that would give you 6/9, which is 2/3, and 2/3 is certainly not 2/5. So you want to times both sides by 5. So if you times this side by 5, you'd have to then work out what this is on the calculator and times by 5, which I'm going to do now. So 1 divided by 1.16 times by 5, and I get 4.31, which seems quite scary. So if I minimize this, it seems worrying enough because this number here would be, and I can write this up here, it looks like 4.3103 and that's in pounds. And we wanted to see the difference between the £2.50, don't forget, and this. So if you take one away from the other, then I get 1 point, so the difference this time is 1.8103 so on pounds. I shouldn't really write that, to be honest, but 1.8103 to pounds and pence, that would be £1.81. So it's either £1.81 in pounds or 2.9 euros. To be honest, I find these questions reasonably difficult. Okay, they're not necessarily my favourite type of questions because I can easily misread a question and put in the wrong thing in a calculator, for definite. So watch out for those, but maybe you like them. There's another question lurking here at the bottom of the page, so let's have a look. Number 7. Here are the first 5 terms of an arithmetic, just think arithmetic, but it's pronounced arithmetic sequence, which means you've got a sequence going up or down by the same number each time. So it's like adding or taking. Geometric is when you're timesing or dividing by the same number each time. So arithmetic for GCSE, and let's have a look. First of all, I'm going to see if there's any pattern. So I can see it goes up in 4s. And so I know it's definitely got something to do with the 4 times table. And notice I'm writing this directly underneath each term. Now, how are they different from the 4 times table? Well, if I do the 4 times table and I always take 2 off, I'll get to the sequence that I wanted. So, try and think about this. If you've been taught sequences well at school, then your teacher would have mentioned that n would generally start 1, 2, 3, 4, 5, and so on. And if that's the case for n, then 2n would be 2, 4, 6, 8, 10. It'll be double the amount. So you can look at n as being the 1 times table and 2n as the 2 times table. So we definitely know that the sequence that we want is to do with the 4 times table, but we've got 2 taken off each time. And just to test that, if we write the 1 times table over the top, 1, 2, 3, 4, 5, then the 5th term is when n is 5, and we'd have 4. 4 times 5 is 20, minus 2 would give us the 18. So I would definitely say 4n minus 2 is the expression. Now, some people write something like t equals 4n minus 2. That's not an expression. Expressions don't have equal signs in them, so don't overdo it and put something like that. 4n minus 2 is fine. Now we've got QWC, quality of written communication. Is 86 a term in the sequence? You must give a reason for your answer. Now, if you're getting stressed, you'll probably add 4 to this until you go off the page, something which I don't necessarily recommend, and I'm not going to carry on because it'll take probably too long. But we know that any number in this sequence can be represented by this expression. That's why it's called, in terms of n, the nth term. So n stands for whatever you want. So first, second, third, fourth, fifth, whichever one you want, this is how you represent it. So can 86 be represented as this? Will 86 be represented as 4n minus 2? Well, let's have a go. Let's add 2 to both sides. And we'd have 88 equals 4n. Divide both sides by 4, and we'd have 22 equals n. So yes, n's a nice whole number, and it would be the 22nd term in the sequence. So I would say yes, because I have shown it being 86 will be the 22nd term. Okay, let's move on. Now it says the frequency table gives information about the heights of some people, and we've got to draw a frequency polygon. Now poly means many, and gon, G-O-N, is really for points. So it means many points. So when you've got, say, 4 points, you can make a quadrilateral. You have 3 points, you can make a triangle, whose old name used to be trigon, 3 points. So we want a polygon, so we're going to be looking at the frequencies. So it's probably going to be 6 points that I'm going to be drawing, and I've got to make a polygon. And that's all there is to it. So let's have a look. Now, if you've watched my other videos on past papers, then I'm very consistent with how I do the explanations, and I've talked about central tendency before. So for example, if you're talking about the heights and you know there's 2 people who have heights between 160 and 165, then you would generally put your money on them being at the halfway point, because when you've got a very large distribution of many people, height nearly always tends toward being more popular around the centre. Okay, it's the same with IQ, height, weight. Many things have central tendency. So I would say this time, you know it can't be 160, but as good as, because height is continuous. So I would say halfway would be 162.5, and I've just got to plot that against 2 here. So let's try that. So we'll have 162.5, and I've got to go, the frequency's got to be up by 2, so my first point will be there. My next one will be halfway between 165 and 170, so if you're not sure, you can always add them and halve them, which is always the mean of the 2 endpoints. So we get 167.5, and we'd go up by 5. And then 172.5, 10. And then 177.5, 21. And then 182.5, 16. And then 187.5, 4. So that would be my frequency polygon, and now I just have to join the points up with a ruler, and it's not smooth. Just think of a polygon as having flat sides, okay, not curved. So there's our first one, second one, third one, fourth, and lastly, there we go. Not a brilliant one. Try that again. Slightly better. Now, you wouldn't really blame students for doing this, because they'd read this word polygon and think it's got to join up. However, that would not be a good idea. You'd only gain 1 mark. That's my experience. You'd gain 1 mark only if it was worth 2. So just leave the points there. Understand that, okay, polygon means many points, okay? It doesn't always have to mean join them all up to the start, not in this context anyway. So just think polygon, many points, and then you won't be joining those up. So I think that's it for that question. Yeah, and we can now move on. I think looking at this question, I'd probably, first of all, we've mentioned this a number of times, QWC, and then I'd probably look at the total present, so 2, 11, 15, 18, 22, 10, 13, 16, 17, 19, and then 3, 4, 5, 6, 7, 8, 9, 10. So 1,092 were present out of 9, 11, 12, 20, and then 4, 10, 16, 19, 21, 2, 4, 6, 8, 10, 12. So out of 1,210. And then I wouldn't attempt to do that without a calculator, to be honest. So if you get 1,092 out of 1,210 on the calculator, which I'll do now, I would get approximately 0.90248. That's to 5 decimal places. And if that's the decimal, and this is the fraction, so you've got fraction, decimal, then to convert into a percentage, think about it. If 100% is 1, then 50% will be 0.5. So 60%, 0.6, and 90% would be 0.9. So you can see 0.9 here. So you just follow this through, and then you've got 90.248 to now 3 decimal places, and that will be a percentage. So you say overall that 90.2% of the students were present, and that would be the simplest way for me to actually do it. So you would say, has the school met the target of 94%? No, only 90.2% to 1 decimal place were present. So I don't think there's a massive amount to that question. So just try and look at the facts, total number present over the total number of students. I think if you try to do it as 192 out of 208 and had that percentage, and then did this one and so on, I think you'd be taking up a lot of time, because overall it's the total out of the total present out of the total, and if that falls short of 94%, then it's game over. So don't make too much of a question like that, is the advice. You know, I've had much discussion about this type of question with my classes in the past, especially my current Year 11 class. If we put 5 in here as x, then we'd have 5 cubed minus 2 times 5. And what would that be? Well, you can use a calculator here. You'd have 125 minus 10, which would be 115. Then I would try 5.1 personally, because that was reasonably close. And then I'd use a calculator for this part. So 5.1 cubed minus 2 times 5.1, and I get 122.451. We're getting closer. I'd then go 5.2 cubed. So 5.2 to the power 3 minus 2 times 5.2. There's quicker ways of doing it using the ANS key if you wanted, but I get 130.208. Now, here's a situation. 5.1 gave 122.451, which was not enough. 5.2 gave 130.208, which was too much. So logic would tell you, if you went for the midpoint now, which I strongly advise to do, halfway, and that method for finding solutions to things goes right up to the highest levels of A level. So we're cutting the interval in half, we're bisecting the interval. So we're going to just go halfway and try 5.15 to the power 3 minus 2 times 5.15, and I get 126.291 to 3dp, which again is a little too much. However, if we know that 5.1 is not enough and 5.15 is too much, then what do you think the answer would be to 1 decimal place? So have a think about it. Well, hopefully you've come to the conclusion that if 5.15 is too much, then you'd probably have to go slightly underneath. Even if it was something like this, it would still be acceptable perhaps to be 5.149987. That's only very slightly underneath 5.15, which was too much. So if you think about it, to 1 decimal place, 5.15 rounds to 5.2, but this was too much. So we'd have to go slightly less than that, and as soon as this number drops to below 5, say something like this, then to 1 decimal place it would have to round to 5.1, and so to 1 decimal place I would clearly say 5.1 for that reason. So a quality of written communication question. It says each table has a diameter of 140 centimetres. Each person needs 60 centimetres around the circumference of the table, and it says there are 12 of these tables in the conference room. So there's going to be a total of 90 people, and you've got to say, will there be enough tables in the conference room? Well, let's have a look at one specific table. So we know we've got the diameter, and we know that wraps around the outside pi times, so we know the circumference is pi times the diameter. We know how to find the circumference then, which is pi times the diameter, which is 140 centimetres. That's what our answer is going to be in. So we work that out, so we can use the pi button on the calculator, and we will get pi times 140, so that will be approximately 439.8229715. I'm just writing down exactly what's on my calculator display. There's no harm in that at all. And that's for one table. So you've got to say to yourself, well, how many people could fit around that table? So if it's 60 centimetres around the circumference, how many 60s would go into that? So we can then say 439.822975 divided by 60 would be, divide that by 60, we would get roughly 7.33 people per table. And we've got 12 of these tables. So if we then had 12 tables at 7.33 people approximately, and you work that out on your calculator again, which is where calculators can be very useful in these types of problems. So we would get 87.96, which is roughly 88 people. You know, because my logic tells me they're not strictly going to have 60 centimetres around the circumference of the table, but we've got to go with that. So we're hovering around the 88 mark. You know, safe to say 87, I guess, is probably better. But we're not going to hit the 90, are we? So there's not going to be enough tables to suit the criteria that we wanted. So I would say you'd need an extra table. So 13 tables needed. I'm sure there's other ways of doing that question, but they'll all revolve around C is pi d and fitting 60s around the circumference each time. So no more to be said about that question, apart from making sure you've written the word no. Not enough. So next question. So for this question, we've got to draw the graph of y equals 2x minus 3 from values of -2 to 3. Well, let's have a look at what grid we're presented with. So we've got to get all our information on there. So what I would do is, I would personally, in this instance, draw an XY table. I wouldn't normally do that, but in this case I will, because the axes are not drawn for you. So you want to just make sure that you've got those values all there. So -2, -1, 0, 1, 2 and 3. Now the nice thing about this straight line is, if I write it out here, it has a gradient of 2, which means all its values will go up in the 2 times table from any point that you start with, and it'll have a starting point, an intercept, so this is the y-intercept, and y-intercepts, as you should know, all start from when x equals 0. So when x is 0, we'll have -3, and you can see that from here. If you have y equals 2x minus 3 and x is 0, this part will be 0 and you'll be left with -3. So personally, I would use the fact that this sequence here of numbers would go up in the 2 times table because the gradient is 2. So -3 goes up 2, it'll be -1, which goes up 2 to be 1, and so on. And then if it goes up in 2 this way, then it will go down in 2s. So you think to yourself, something and 2 is -3. So what do you think that something would be? Well, hopefully you've worked out it's -5, because -5 add 2 is -3, and then this one here would be -7, because -7 and 2 will be -5. It's just a nice way that helps you get the answers quite quickly. So let's have a look. So we know we've got our axis to draw, but we need to make sure that we compensate for some of these negative values that go down quite a lot Okay, they don't go up quite as high as they go low. So I would probably draw my x-axis here. I'd obviously use a ruler if I was in the exam. And we want -2 to 3, so it's not quite straight in the middle, so I'd probably have something like this. And I'd label this as my y-axis, and this is my x-axis. Never forget to do that. And then you can put the values in. You can put 0. You haven't got to put every single value in. So you might just want to go 2, 4, and then -2, -4. But we're only going to be plotting the values from -2 to 3. So, and then we're going to have y is -7. So again, we can have 2, 4, 6, 8. There's -8 there. And then we can have 2, 4 up to here. Now some of you would argue that, well, we're not allowed to put values of more than -2, or sorry, less than -2 here. We've got to stop there. I don't know if I agree with that. As long as you don't plot any other values. It says draw the graph from x is -2 to -3, so I'm definitely going to make sure I abide by the rules there. So we'll start with -2, -7. So this will be 2, 4, 6, there's -7 there. So that's my first point. I'll probably do that in a different colour. There. And then -1, -5, 2, 4, 5. And then 0, -3. And then 1, -1. And then 2, 1. And then 3, 3. Okay, so what I would then do is I'd then link these up here. So if I can get this right. Okay, not perfectly straight, but that's what I would do. So I am abiding by these rules, and I'm going from the 3 down to the -2. But there's no harm in doing your scale like I've done there. If you want to get too worried about it and go up in ones, then be my guest. I don't really like it too much when you see all this stuff going on here. It crowds everything a bit too much for me. So that's how I would do it. This question, let's see if there's any more to it. No. I think what I might do is I might just label it y equals 2x minus 3 there, and then I'll move on. So for this question, you've really got to work out the volume of the swimming pool. There's no two ways about it. And then let's think of the rate at which it's filled later. So I think what we've got to really realise fundamentally is that if we look at the actual prism itself, now when I say prism, I mean that this cross-sectional area is pushed back by a certain length. I think it's worth noting that really we have this situation going on here. So we've got a triangular wedge, so a triangular prism here, which is right angled here. So I'd look at that separate to the cuboid on top. So we're going to look at the cuboid first, and that's easy enough because that's just length times width times height. So pick a point here, and then we've got the length times the width. Doesn't have to be the width as in the widest, or length as in longest, but one of the dimensions by the other, which is 15 by this one, which is 1. So the cuboid has a volume of 150 meter cubes. Now, the triangular part is always going to be a problem for people, But if you just imagine that it's a cuboid halved, then there should be no problem. So if we look at the triangle here, triangular prism, we would have, again, pick a point here, do a different colour. So we'd have this one here, which would be, now you've got to be careful with this, because it says very clearly here that this length from here to here is 6, but all of this length here to here is 15. So you're going to have 9 here by, well, it was 2 all the way, and so it was 1 there, so that leaves 1 for this, by, well, that's okay, that's 10 again. So that's going to be 90 meter cubes. But now make sure that you halve this value, because for the triangular part we wanted to halve what the cuboid would have been. Okay, so we need 45 meter cubes for the triangular part. So adding those together would give us 150, and 45 is 195 meter cubes. You won't need a calculator for that. Now, 1 meter cube is 1,000 litres, so we've got 195 times 1,000 litres, which, if you just say it, 195,000, it's easier to write. So 195,000 litres, and it's 50 litres per minute. So to work out how many minutes, we just take 195,000 and divide it by 50. And how many minutes would that be? Well, I worked that out to be 3,900 minutes. Now, this is not quite over yet, this question, because there's still room for making mistakes, no matter how able you are. I would say that 60 minutes is 1 hour. And then if you think to yourself here, how many 60 minutes go into 3,900? Well, you can work that out by doing 3,900 divided by 60 would tell you how many hours. So we'll divide that by 60 and we'd get 65 hours. So there's quite a lot of room for error here. Even if you're very, very able at maths, you could forget to halve the cuboid to get the triangular part. You can easily make a mistake on the calculator. That's why I keep saying to my students, you must show the stages of your working, because the examiners are paid money to check carefully whether they're going to give you the mark or not. So they will scan all this space really carefully to see what you've written. Okay, that's what they're paid to do, and they will just mark hundreds and hundreds of question 13s for days on end. So put the stuff on there. Okay, let's have a look if there's any more to this question. Well, I think I'll have to turn the page and go to the next part of this question. For this question, I think you've got to be really careful, because if this is the line MN here, and you want to start filling the water from there, you've got two different types of prism to fill in terms of the swimming pool. You've got the triangular part underneath, and you've got the cuboid part on top. So I'm almost certain that most of you would rule that one out, because there's no change there, it's constant. It's saying the rate of which it's being filled here is going to be constant, and that can't be the case, because there's a change in the shape completely. I would also say that if you look at the triangular prism part, it's not going to be constant, i.e. linear. What's going to happen is, as you start filling from the base here, it's going to be reasonably fast here, but then it's going to slow down as the surface area increases. So I would say there's going to be a slowing down here, which this one could represent. This one could represent, but I'm afraid this one kind of gives itself away. That can't be the case, because it's not going to increase at a rate at the very beginning. That's not going to happen. So this one goes goodbye to B. A's gone. So it's between C and D. Now, try and use your logic here. As we've filled to this point here, so we're now level with the base now, we're going to get a reasonably sudden change in rate here. And because there's a more of a surface area at each time to fill, to create the volume, the rate is going to decrease. But it's going to decrease to a situation where it's not going to just keep decreasing. It's going to decrease, and then as you start filling this part, it's going to be constant. So I'm afraid this part is just not constant enough. Okay, so this one here would be the answer that I would go for. Now, if I haven't explained that very well, then I do apologise, but that is my only way that I would personally do it. I would do it by deduction, and I would rule out the other ones. I certainly wouldn't be guessing here. It's too valuable a mark. So C would be my answer, and there we go. Well, this question is quality of written communication, and Peter has £20,000 to invest in a savings account for 2 years. He finds information out about 2 savings accounts. So let's have a look. At the end of 2 years, well, if you put £20,000 into the, now this is the bonus here, the bonus saver, then if you wanted to get 4% for the first year, then at the end of that first year, you'd want to not just find 4% of the 20,000, but add that onto the 20,000. And the quickest way of doing that is to times this by 1, which gives you the 20,000. And then if you think about 1 plus what 4% is, and 4% is 0.04 as a decimal, then you'd have the 20,000, and then you'd also have 4% of the 20,000 added on. So if you do 20,000 times 1.04, that will give you what is left at the end of the first year, which works out to be £20,800. But then each successive year after that is 1.5%. So it's compound, so it means that you take what's at the end of year 1 and then you apply the successive interest rates to that amount that you have at the end of the year before. So if you have 20,800, and we'll label that as year 1, don't forget, then we want to add 1.5% on to the 20,800. So we want to do 1.5% of 20,800 and then have that added on to what we started with, which was 20,800. So we're going to times it by 1. Think about adding this 1.5% on. Now be careful, if 0.04 was 4%, then 0.02 is 2%, and 0.01 is 1%, so 0.015 will be halfway between these two, which will be 1.5%. So you want to add 0.015 to this, so we're really doing 20,800 times 1.015, and we'll do that quickly. And I get, at the end of year 2, I get £21,112, and that's end of year 2. So that's in the bonus saver account. In the fixed rate account, however, we have the £20,000, the principal amount that we're trying to save, and we've got 2.5% compound each year. So we want the end of 2 years. So by the end of year 1, this should be easy now, 1.025. We'll get our answer here. So we'd have 20,000 times 1.025, and that would be £20,500. That's year 1 end. And then we take the 20,500 and apply that again, and we'd get £21,012.50, and that's the end of year 2. Now there was a quicker way of doing this second one. You could have just done 20,000 times 1.025 squared. Why? Because you've got 20,000 times 1.025, which is what you've got over the first year, and then you're timesing that by 1.025 again. So notice that's 1.025 squared. Okay, so again this is the multiplier. So it seems to be that at the end of year 2 you would get more here. Okay, so you get more in the bonus saver. So you would just say choose bonus saver. If you want to really get the examiner to see what you're doing, you can write less here. Okay, so there we go. That would be the answer for that question. For this question, you've got to be really careful. You just got to think really clearly. It says that 3 adult tickets and 1 child ticket is £30. That's the cost. And 1 adult ticket and 3 child tickets is £22. So that's the total cost. So what you can say is, you can say the cost of adult ticket, just let that equal, say, X. So it's got to be the cost of the adult ticket, and the cost of the child ticket, just let that equal Y. So don't forget, we're talking costs here because this is what you've got to find. So in the first situation, we've got 3x plus y is 30 as a total cost. And in the second scenario here, we've got 1x plus 3y is 22. So what we need to do is just solve these simultaneously. Now, if I label these A and B, you may not do that in the exam, it's up to you, but I'm just doing this so I can explain it. I would personally times equation B by 3, and the reason is I would then have 3x plus 9y equals 66. That then becomes equation C. And then I'd be comparing A and C, because then I've got the coefficients of x the same. Now the way I do simultaneous equations is I never take them away. I always times one of them through by -1. So it saves me having to work out with horrible negatives. So I will times, I think I'll do this one by -1. So just change the pen. So I'll times that by -1, this by -1, and this by -1. And then I'm going to do equation A plus C now. So I'll end up with minus 3x and 3x is 0. I'll then have negative y and 9y. Well, that's going to give me 8y. And that's going to be equal to negative 30 and 66, which is going to be 36. I'll just keep these colours the same. And then y will just be 36 divided by 8, which is going to be 18 divided by 4, which is 9 divided by 2, which is £4.50. So you'd say £4.50, and that's going to be a child ticket. And then once you've got y as £4.50, you can either substitute into one of your original equations, and don't forget the original ones were 3x plus y is 30, and x plus 3y is 22. So you can either substitute y is £4.50, and in fact the easier one to do it in is probably this one. So that's equation A. So we can say sub in A, and then we can say 3x plus the 4.5. Now in terms of pounds, 4.5 is equal to 30. So we can take 4.5 from both sides. So we'd have 3x equals 25.5. Now be careful with this now, because if I know you've got a calculator, but I'm really trying to help you with your number skills as well. Don't rely too heavily on it. Of course you can all do 25.5 divided by 3, but if you noticed about the digits 2, 5, 5, they add up to 12, and 12 is in the 3 times table, so 3 should go into this nicely. So 3, 8, 16, 24 with 1 left over, so you've got 8.5. So if you divide by 3, you'd get x is equal to 8.5, and that's going to be in pounds now, so that's going to be £8.50, and that's going to be the adult ticket. So there you go, £8.50 and £4.50. Well, a reasonably tricky question. You've got to look at the bars of the frame and work out the total length of them. So we've got one bar here. I know this is pretty obvious, but not to everybody. So there's the bars. So that's 1, 2, 3, and then 4 across here. So I think the first thing I'd look out for is Pythagoras in this triangle. So I'd say Pythagoras in triangle ABC, and we'd have, don't forget our little aide-memoire. I would say when you've got a right angled triangle, just draw the squares on the sides, and it's the 2 smaller squares that make the larger one. So in this case we've got 3 squared for this one, which is 9. For this one we've got 5 squared, and that's 25. And we're adding these 2 areas together to get the larger one. So this area is going to be 34. So the length is going to be root 34, which you can just leave as that for the moment. So that's this length here. Now what that means is that we've got the length of 3 of the bars. We just need to find the length of this last one here. Now personally I would start to have a good look at what we have, and we've got this length, we've got this length and this one, and what we need to do is find the length BD. So I personally would begin to look at the triangles separate from each other and try and find any clues that can help me find the length BD. So I'd pretty much say that we have this angle in the triangle ADB, but in the larger triangle ABC, we have this length here as 3, and we also have this length here. So we may as well find this angle A, because angle A is also common to the triangle ABD as well as the triangle ABC. So I'm going to go with that first. So don't forget you can use SOHCAHTOA as long as you understand where that comes from. And I've done videos on the unit circle to give you a good understanding of where that can be applied and why. And in this situation we have an angle we want, we have a length which is opposite the angle, and we have a length which is adjacent to it. So we're using tan. So I would say the tan of the angle A would be opposite over the adjacent, and therefore A would be inverse tan or arctan of 3/5 in degrees, which I'll do now. And that gives me A, and I'd write all the numbers out on my calculator display, 96375,653. That's in degrees. I wouldn't start to round this to 3 significant figures, I'll just leave it well alone for now. So I've got this angle now, and I've got this length, so I should be able to find BD. So the way I'm going to do that is to draw out a separate triangle. You may or may not do this in the exam. You may feel you've not got time. I would suggest you have. A good diagram can save a lot of time and a lot of panic. So I'll just have A, B and D here, and we've got the right angle here. Let's put in the information we know. We'll put a tick there because we know that angle here. Notice I haven't rounded this at all. I'll say that again, don't round, because if you round and then reuse a rounded answer, you've rounded it even more. So we'll call this length D, and then we'll look carefully. We want to use the opposite, and then now the hypotenuse. Don't forget, hypotenuse always opposite the right angle. So we've got the sine now. So we've got the sine of angle A, which we know is equal to opposite over hypotenuse. So if we times both sides by 5 to get rid of this denominator here, then what we'd be left with is 5 sine of A, which we already know, is equal to D. So I'm now going to put all of this in here. Some of you may use the ANS button on your calculator because it's the last thing that's already stored. So I will have 5 sine ANS, and I get D as 2.572478777, and that's brilliant because now I'm ready to sum all the lengths up and find the total. So I will have root 34 plus the 5 plus the 3 plus the 2.5724 and so on, which is in my calculator already, so I haven't got to add that again. So I'll start with what's in my calculator, plus the 5 plus the 3 plus the square root of 34 and I will get a total of 16.40343067. Now round to three significant figures, which in this case is to the nearest tenth, and I would get 16.4, and I'm going to write 3SF right next to it. So that's that question sorted now. Right, so in this question, you've got A, B, C and D are points on the circumference of a circle, and you're given two angles, and you've got to work out the size of angle DAC. So D to A to C. So you want this angle here. Well, what I suggest you do is look carefully at what you do know and try and use some of the facts that you can actually work out using some logic. There will obviously be some circle theorems coming into play here, but let's have a look at the diagram carefully. Well, the first thing to think of is that this angle here, I'll do with the double bar here, then you can see they should be the same. And why do you think that is? Well, if you look at this minor arc here, then angles that come from the same arc are equal. Okay, so that's the first thing you can note. So they're going to be the same. You know that this angle here is going to be 80 degrees because angles on a straight line are 180. So you know that this angle is 80 because it's opposite to the other 80, or it's on the same straight line as the 100, because angles on a straight line are 180, and you know that this angle is 100 for a mixture of two things. One, that it's opposite this one, and also it's on a straight line where there's already an 80. So we know those two, and then we also know that angles in a triangle, so this triangle here, angles in a triangle up to 180, so we've got another 55 degrees here. Now, if we know that that angle is 55, then there's one quite important feature now that comes in, and that's this one here. So the way I'm doing this question, I'm purposefully making you think about what it could be. Well, if you look here, you've got a diameter, AC, and you've got a point here, B. Right, so can you see the circle theorem now? If AC is a diameter, then yes, this angle here must be a right angle, must be 90 degrees. So you now know that this angle here is 35 degrees, and so this one must be 35 degrees. So what I'm not going to do is, I'm not going to show all this working for you. I've gone around a particular way of doing it, and what I suggest you do is write down the steps that I took to actually get there. And that's what you're going to have to do in the exam. So it's things like angles on a straight line add up to 180, angles in a triangle are 180, and then we use the property that angles from the same arc are equal. Okay, so I think some of you may know that circle theorem as angles in the same segment are equal. There's different ways of teaching it. So you write those ways down, and we can go on to the next question now. Right, so in this question we're asked to work out an estimate for the mean length of time that adults watched TV last week. Now we know that 8 adults here watch TV between 0 and 10 hours, 15 between 10 and 15 hours, and so on. But sometimes it's quite difficult for students to understand which time to actually take here. So here's a little bit of a intro into why that is. If you had X and Y here, and say you were talking about population of United Kingdom, and you were talking about heights, then if you were to distribute all of those heights, you would find that the population distribution of height here, so x is in terms of the actual height, and you could have that in centimetres, and y would be the frequency, then you would find something called more of a normal distribution. So what that would mean is you'd get very tall people up this end here around the 2 metre mark, and you'd get short people here, and then the average height for an adult, a male adult, I believe is around 1 metre 78. So you'd get the median around here. Now, can you notice that this average here, the median, was around the centre here? Okay, this is called the idea of central tendency. So when faced with a problem like this, I like to have that diagram in mind and think, okay, I want to be looking at the midpoint. So if you had another column here, the midpoint, and the midpoint between two numbers is always if you add the two extremes up. So if you add 0 and 10 together and do the average of them, so 0 and 10 is 10, halved is 5. That's what you would take all of those frequencies to be. So you would say the frequency of 8, so all of those 8 adults, you would say, well, let's assume they all watched 5 hours of TV, because some could have watched 1 to 2 hours, some could have watched 9 hours, but they would probably tend more around the centre. Okay, so we'd have 8 lots of 5 and 15 lots of, 15 and 10 you can do on the calculator, halved is 12.5. The next one will be 17.5, and then we'd have 25. Because be careful, this was a interval width of 5, this is 10, so be very careful. And this one, 30 and 50 is 80, halved is 40. And then what you do is, on your calculator, you would do 5 lots of 8, which is 40. And then you'd have 12.5 lots of 15, which I'm going to do on my calculator. So we'd have 12.5 times 15, which is 187.5, plus 11 lots of 17.5, which is 192.5, plus, I should be able to do this one, 10 lots of 25 is 250, plus 6 lots of 40 is 240. So if you added that up, that would be all the total hours watched. Okay, your estimate for that, but you want to find the mean, so you'd have to divide by, and here's where a common mistake is, some people think it's divided by 1, 2, 3, 4, 5. No, there's 5 different sections here, but how many people or adults were asked? Well, 8 and 15 is 23, 11 and 10 is 21, and 6 more, 6, 9, 10, 2, 4, it's 50 people, 50 adults you're talking here. So your mean is going to be all of those added together, which is going to be 40 plus 187.5 plus 192.5 plus 250 plus 240, which gives you a total of 910 divided by 50. You've got a calculator, but I know that the answer there should be 18.2, and that'll be 18.2 hours. Okay, that'll be the mean length of time. So let's have a look at the next part. Here we've got to draw a histogram. Now, don't worry about histograms too much. I usually tell my students that when you've got one of the bars, the area of the bar is the total frequency. So in this case we've got 0 to 10 here, and that means that this measures 10, and 10 by something has to give 8. Well, if you do 8 divided by 10, you're going to get 0.8. So if we call this column here frequency density, or FD, I'll write the keywords here, frequency density. And think about the density of something is how tightly packed it is. So you're packing these bars with frequency. So the first one is going to be 0.8. Why? Because 0.8 times by the 10 which we knew is going to give us the 8 that we wanted. Well, this one, 5 times something is 15. Well, that's going to be 3. This one, 5 times something is 11. So 5 times something is 11. Well, do 11 divided by 5 and you'd get 2.2. And then 10 times something is 10, that's 1. And then 20 times something is 6. Well, that something will be 6 divided by 20, which is 3 divided by 10, which is 0.3. So you can just write those down. You can call the column FD. Okay, and then all you do is you just carefully plot these now. So the scale, you've got to choose your own. So it goes as high as 3. So you could go 1, 2, 3. And then we want to try and get 0.8 in here. So we'll cross off the 3, we've done it. And then the 1 we can have here, we've done that one. And then we can look at the others. So let's start with the 0.8. So we've got to have 0.8 here somewhere. So that's going to be here. Okay, because that's 0.5, 0.6, 0.7, sorry, it's here, 0.8. And it's got to be 10 wide, so it's going to be like so. And you'd use a ruler, obviously. Okay, and that'll be your first one. Now we want this one, so it's a depth of 5, so it's going up as far as here, which is the 15 mark, and it's got to be as high as 3 because that was its frequency density. So it's going to be a very long, narrow one here. Okay, so that's done. Now we're going to look at the next one, and that is 5 wide here, that's its width, and its height is going to be 2.2, so you can label a 2 there, and 2.2 is here. And then we've got 1 and it's 10 wide here, so that's a nice easy one to do. There we go. And then we've got 0.3 and a width of 20, so the 20 width is here, and I go 0.3, 0.1, 0.2, 0.3, and there you go. That's your histogram almost done. Yep, it has labelled the length of time here. We wouldn't want it to dock marks for us here, so we've got FD for frequency density labelled, length of time is labelled, and we've drawn our histogram. Okay, so don't forget the area of the bar is the total frequency for that particular class interval. Well, let's see if there's any more to look at. No, that's there. That question done. So let's move on to the next question. So Louise makes a spinner. The spinner can land on green or on red. The probability that the spinner will land on green is 0.7. So let's fill this in. Probability it will land on red will be 0.3. Got to add up to 1. And then Louise spins the spinner twice. Complete the probability tree diagram. Well, it's always going to be 0.7 for green and 0.3 for red. So that's easy enough. Now, I do have a little video somewhere about why you multiply at these junctures here, and I'll put a link on here if I remember. So we want to complete the tree diagram. Well, we've done that, and then we want to work out the probability that the spinner lands on two different colours. So the way I do it is I look at a journey, so it can be green, then red, or it can be red and green. So these are the leaves on the probability tree that I want to pick. So how do I get to this end point here? Well, for this journey I go 0.7 times 0.3, and for this journey here I've got 0.3 times 0.7, well, 7 3s are 21 and 10 10s are 100, because you've got basically 7 tenths times 3 tenths, which is 21 hundredths. So you've got 21 hundredths for here and 21 hundredths here, and then in total you'd have 42 100ths, or 0.42. So you can give your probability as a decimal. Don't have a decimal more than 1, because that would be impossible, or a fraction. I just want to finish this grid off just so you can see here that if you multiply these two here, you'd get 0.09 or 9 100ths. And then if you add these up, 21 hundredths and 9 hundredths is 30 hundredths, and 21 more is 51 hundredths. So I already know that this is going to be 49 hundredths. It has to be, because it has to add up to 1 in the end. And yes, 0.7 times 0.7 is 0.49, which is 49 hundredths. So, you know, always check that you'll get 1 as a total here, as a decimal, or 100%. So, I don't think there's any more on that particular question, no. So we can move to the next one. Well, this question here can be done in many different ways. I would say the most popular ways would be completing the square or the formula. So probably the quickest way would be to use the formula that's given, and you get minus b plus or minus the square root of b squared minus 4ac all over 2a, and you can find that on your formula sheet. And if you look at 3x squared minus 5x minus 1, then a would be 3 in this case, b would be, very carefully, negative 5, not 5, and c would be negative 1, and we can just plug those into the formula. So we get minus 5, which is 5, plus or minus the square root of b squared. Well, anything squared is positive, so negative 5 times negative 5 is going to be plus 25, minus 4 times a times c, which is negative 1, all over 2a, which is 6. So very carefully work out what's inside the square root sign, otherwise known as the discriminant, which some of you may know as the discriminant, b squared minus 4ac. So be very careful here. A negative times a negative at some point will be positive, so you'd have 25 plus 12 here, all divided by 6. So you'd have 5 plus or minus the square root of 37 all over 6. Now, that's one way of looking at it. Another way of looking at it is to say 5 over 6 plus or minus root 37 over 6. And then for some of you, you may see that as the line of symmetry, which it always is. Now, when you want the actual values, you would see that you have the plus or minus, and this would determine that there be two values. So your first value would be 5, and I'll go from here. it'll be 5 plus root 37, all divided by 6. So when you do it on your calculator, put a bracket round here. So I'll do that one first. So on my calculator, let's have a look. 37 to the power 0.5 plus 5. That would be 11.0827. So I will do the numerator first rather. 11.08276253, and then I'll divide that by 6 at the end, and I would get, and it wants it to 3 significant figures. Well, don't worry about that too much just yet. Just write down what your calculator display says. And then your second solution would be 5 minus root 37 over 6. And some of you can use your calculator in faster ways than me. So 5 minus 37 to the power 0.5. I say to the power 0.5 because that's the same as square root. And some of you have different calculators. As long as you make sure you've got a bracket here if you want to do it all in one go. So I get the numerator as negative 1.08276253, and then I'll divide all that by 6, and I would get my second solution as negative 0.180460417. But I want it to 3 significant figures, so let's have a look. There's my third significant figure to the nearest hundredth here. So it's 1.85, so I'd say x1 1.85 to 3SF, and then this one to 3 significant figures. Well, I nearly got it wrong myself there because this has no significance, so it's 1, 2, it's going to be this one. See, it's very easy to make a mistake. So the third significant figure is going to be up to here, so I would say x2 is negative 0.180 to 3 significant figures. Okay, so that's how I'd give my answer doing it that particular way. However, some of you may prefer to do it this way, and that is 3x squared minus 5x minus 1 equals 0. You can add 1 to both sides. So you'd have 3x squared minus 5x equals 1. Divide everything through by 3. So divide both sides by 3, and you'd have x squared minus 5/3 x equals 1/3. Then you can complete the square. So you'd have x minus 5/6. And I've got plenty of videos on that as well if you want to have a look through the playlist. X minus 5/6 squared minus 25/36 equals 1/3, and then add the 25/36 to both sides, and you'd have x minus 5/6 all squared equals 25/36 plus, well, 1/3, you can change that into 36 by timesing top and bottom by 12. So you'd have 12/36, and there you get your 37 coming in. And now you can square root both sides, so you'd have x minus 5/6 is plus or minus the square root of 37/6, and then just add 5/6 to both sides. So you'd have 5/6, which is the line of symmetry, plus or minus root 37 over 6, which is what we had over here. So it's really up to you how you want to do it, but when you get to here, you're still going to have to decimalize anyway. So I would say most people would probably use the formula. That's absolutely fine, but don't keep your eyes off this kind of work here, because that's really important too. In fact, I would argue that this is probably a little bit more important to you right now than this, especially if you want to go on to do A-level. I know that algebraic ways of doing things definitely override just plugging into a formula. You should be able to prove the formula from scratch anyway, and I've got a video on that if you want to have a look at it. So that's that question there. Let's move on. In this question I have two triangles. I have triangle ABD and triangle BDC, and I've got to find the length of BC. So I'm just going to draw a red line here so I know what I'm looking for. And generally in these kinds of questions, especially getting towards the end of the paper, you're going to be looking in probably this triangle first before you look in this one. So in triangle BAD, I'm definitely going to fill this angle in as 55 because I already know the other two. And in triangle BDC, I'm going to fill this in as 100 because angles in a straight line are 180. And I think the first thing I'm going to do is realise that if I can try and find the length BD, that could unlock the door to finding BC. So in triangle ABD, I'm going to use the sine rule. Now the sine rule's at the front of the paper, which you can have a look at any time, but you probably have a rough idea of what the sine rule is. So you may know it as sine A over A is sine B over B is sine C over C, or you can invert both sides and have A over sine A is B over sine B is C over sine C. Now generally you would use this form if it was angles you wanted to find because they're basically on the top each time. It doesn't really matter if your algebra's very good. If your algebra's reasonably good, however, and you want to find a length, then use this one because the lengths are already on top waiting for you. So let's have a look at triangle ABD, and we want to find a length, so we're going to use this one here. So we're going to say 7.4 over the sine of the angle opposite it, which is 80, will be BD, which is the length I want, over its opposite angle, which is sine, well, the opposite angle is 45, but I want over the sine of 45, and that will be equal to AD, which I don't know, over the sine of 55. Well, in this kind of situation, you've now got to look at the identity and say, which ones would you use? Well, I've definitely got to use this one really, or there was no point in even using the sine rule because BD is what I want to find. And you certainly don't use something else which has an unknown. So as this has an unknown, that's gone. So you just put these two equal to each other. So you may know what the sine of 45 is, which is root 2 over 2, or 1 over root 2. If you don't, it's no big deal. You can just times both sides of this equation now by sine 45, and you would have BD equals 7.4 sine 45 divided by sine 80. And I strongly suggest when you use your calculator is to put a bracket around this and do it, and then divide it by sine 80. When I say this, if you're not as strong with algebra or trigonometry, just work out the top part separately and then work out the bottom part separately and then put them into your calculator by saying top part divide bottom part and then write your answer down. Don't always try and do everything at once because you may lead to more errors. So in this case, BD should be perfectly doable, and I get BD as, I don't write equals here because it's not, it's rounded because the calculator has to round, 5.313311,319. I'm definitely going to refer to that later. So how has that particularly helped? Well, this is in centimetres, and I want to now think about the red line that I wanted, which was BC, but this is in a different triangle. So whether you do this in the exam or not, I don't know. I don't think a good set of diagrams particularly takes too much time. In fact, it could actually save you a lot of time and worry later on. So we've got our D here, there's B and there's C. I want to find BC. I know this is 100 here, and I know this is 5.8, and now I know this as well. So you really can't use the sine rule again because you've not got enough information. So it's going to be the cosine rule. That's what we're going to be looking at now. And I've done a video on the cosine rule and how to remember it. I'll quickly go over, in this case, how I teach my classes how to remember it anyway, after being proven it. And that is, if you imagined we had triangle BDC, I imagine that it's a right angle triangle, and if it was, then you'd have BD squared plus DC squared would be equal to BC squared, but it actually isn't because it's not a right angle. So what you have to take away from this side is always 2 times BD times DC cos the angle. Now that's for any triangle you want to use. You just pretend it's a right angle, so you definitely get these parts on the correct side of the equal sign, and then you always take away 2BD DC cos 100, or 2 times the length times the length times the cosine. But the nice thing about it is that this length and this length here are the ones that always make the angle in question. So there's just a little tip to remember. If not, I would look at my video on the cosine rule, which may or may not help. Hope it does. So let's put the information in now, and I'll try and do it like I would be doing this. So I would say, pretend it's a right angle, so I would have BD squared, which is 5.3133, I'm not going to write it all out, squared, plus 5.8 squared, and that would be equal to the other length squared, which in this case was BC squared, which is the actual length I want to find. But it isn't a right angled triangle, so I've got to take away 2 times 5.313311 and so on times 5.8, and those two lengths make the angle 100, so it's cos 100, hence the cosine rule. So the nice thing about this now is, if I square root both sides, then my answer is simply all of this. It's 5.313311 etc. squared plus 5.8 squared minus 2 times 5.313311 times 5.8 times cos 100, and that would give me BC. So you can put that all into the calculator all at once if you want. Personally, I would do that, but some of you may want to do each part separately. So let's do this slowly here. I think I'm starting by putting this in first. I'm not going to do a square root sign first. I'll do to the power of half afterwards, or keep it as ANS and then do square root ANS. So I've got 5.3133 and so on sitting in my calculator, so I'm going to square that first, then add the 5.8 squared to it. So let's have a look. take away 2 times 5.313311, or the ANS part. I don't have to put the whole decimal in. As long as I've got 4 or 5 decimal places, that's enough for me. Times 5.8 times cosine 100, close bracket. And I get 72.5739 and so on. So now I can just square root that. So I'm doing to the power 0.5, which is the same as square root. You might want to do square root ANS or square root of what you've just written down. And that gives me 8.519036 and so on. And that's in centimetres. But let's just check what it wants it to. It wants it to 3 significant figures. So checking to 3 significant figures here, I would say 1, 2, 3. The 9 will change it, so it's the nearest 100th in this case. So I would say 8.52 centimetres to 3 SF. And I'd be thinking that would be a good answer, and it's correct. So that's the end of that question then. So this is one of the quite difficult questions on the paper now. We've got to simplify fully this expression. Now some people start doing this, and they get answers like 2 and 3 is 5, take away 5 is 0, and then nothing there, 5, and so the answer must be 0. Well, come on, let's have a think about this, because we've got a fraction here and it's got a numerator 2x squared minus 5x plus 3. Now what we're really looking for is 2 brackets that when times together will give 2x squared minus 5x plus 3. So there's many ways of doing this, and I've got videos on this that you can have a look at, so I don't really want to go into too much detail and tell you all the different ways, but one way is to look at how to get 2x squared. So you could have 2x in one of the brackets and x in the other, and then you'd have to then multiply those together and get 2x squared. Now in the bracket where you've got 2x, you've got choices. You've got factors of 3, which is nice because it's a prime number, so it's only going to have 1 and 3. So you could put the 1 here and the 3 here and give it a try. So multiply the grid out, and you'd have 2x squared, 6x and x is 7x, and then you're in trouble. But the 1 times the 3 was fine. So can you see a little change you can make to that grid to get the answer? So let's just go back to here. Well, if you were to think carefully, -1 times -3, that's positive 3. You've got the 2x squared here, and then think carefully. If you do x times -1, so just highlight this so you can see what I'm doing, x times the -1, that will give minus x here. And then here, you'd have -3 times 2x, which is minus 6x. So what would you have then? You'd have minus 6x minus x, which is minus 7x. Well, that's not going to help either. So a bit of advice here is, instead of panicking, just stick with what you've got, get the grid, put these in, because you can't go wrong on these. You knew that the -1 times the -3 was going to give you a 3. But then just switch these here, so have the -3 here and the -1 here. So you're going to get your 3 that you want, and then try and see what you've got. You've got minus 3x here, and then you've got minus 2x. And then you've got what you want because you've got the minus 5x that was so difficult to get hold of. So what I'm saying is, try something in a grid, and then maybe just switch a couple of things round, and you will get the answer. Okay, so you have to be quite patient, but also you have to practice these quite a bit. So the top numerator is going to be 2x minus 3 times x minus 1. And just adding here, there are plenty of methods of doing this, and I'm not going to go into all the methods here. So let's look at the denominator now. So again, we'll look at a little grid, and we'll say we've got to try and get an x squared, so an x in both, and then we want to get negative 6. So let's try putting, say, 6 and 1. Let's just give it a try. Fill out the grid, and then you'd have x squared, yes, 6, no, and then if you added these you'd get 7x. So try and think about one thing you could do to get 5x here. Try and have a think. Well, if you had a negative here, then I'll write this in red. Then if you times the negative 1 by the x here, you'd get minus x. And then if you had the minus x added to the 6x, you would get the 5x that you wanted. And another really important thing to notice here is, when you've got your numerator done, nothing's going to simplify unless you get one of the terms on the top. So look out for an x minus 1 if you can, and look, you have one here. So if you went with x minus 1 here times x plus 6, and just check that again, yes, x squared minus 6 I'd have here, so that's fine, that works out. And then I've got my 5x that I wanted here. Then you're onto something, because now look what happens. X minus 1 divided by x minus 1 is 1, so you're left with 2x minus 3 here, and then x plus 6. So that would be the answer for the first one. And like I said, there's many different ways of factorising, so you need to revise those areas and practice as much as possible. And I'll try and put some links on here to some videos later on. Now let's look at the second one here. I definitely have some videos on rearranging. I have a lot of information on that, so look out for subjective formulae or rearranging equations, and I have some good videos on those that last quite a while, but they've got a lot of questions and a lot of difficult ones. So for this one, let's enlarge this a bit more actually, and we want to make m the subject of the formula. So let's put a circle around what we want. So somehow we've got to isolate the term in m and have m equals something. So let's write this out. So we'll have m over v, let's get my v's looking better than that, v minus t over b equals m minus t all over r. So first things first, let's try and get the terms in m on one of the sides only. Now there's many different ways of doing this. Some people might choose to do this before they do anything else, and that is to call this one m over r minus t over r. And then what you could do is you could take m over r from both sides, and that would leave you with m over v minus m over r minus t over b equals minus t over r. Then you could add this t over b term here, and that would give you m over v minus m over r equals t over b minus t over r. So we're getting somewhere here, because now the nice thing that we have is we have the m term here which we can take out as a factor. Now it's quite a strange factorisation, but it's one that works here. I use a square bracket here. You can use square or curly brackets, doesn't really matter. And then what I'll do is here, I'll factorise this t out. This is just, the icing on the cake, this kind of way of doing it, but we might as well do it properly. And then what we can do is here, And you won't see this happen very much in the exam. Why not just divide both sides by this? And then, look, you will have 1 over v minus 1 over r. And then, let's have a look. I'm trying to show all the steps here. And you'd have m equals t lots of 1 over b minus 1 over r, all divided by 1 over v minus 1 over r. That would be okay. I think that would be perfectly allowable, but I don't know if everyone would have done it that way, so let's try and do it another way. Let's just do it a couple of ways actually, because this is quite a difficult question. I think, and I'm not going to show every single step here because it will just go on too long, so just try and listen to what I'm saying, and then I'll miss out a couple of these steps like this kind of thing here, but I'll show each stage. So let's start the question again. So m over v minus t over b equals m minus t all over r. Well, I think one thing you could do is you could get rid of the r from here by timesing everything through by r. So if you did that, you'd have rm over v minus rt over b equals m minus t. Then what you could do is isolate the m terms on one of the sides. So you could take m from both sides and end up with rm over v minus that m minus rt over b equals minus t. Then you could add this term here to both sides, and you'd have rm over v minus m equals rt over b minus t. And then you could factor the m out here and have r over v minus 1 equals rt over b minus t. And then this may annoy the examiner, but it is perfectly allowable. That could be your answer. But I think there's probably a nicer way of ending up with the answer. But look, at the end of the day, you want to do the rules of algebra and get to isolating m, and you've done exactly that. So no one can pick holes in what you've done there. But is there another way that we can do which might, look a little bit better, but will gain you no more marks? So let's have a look. Well, m over v minus t over b equals m minus t over r. Well, what we could do is add these fractions up so we get a common denominator. So we'd have mb minus tv all over vb is m minus t over r. And then what we can do is we can cross multiply. What you're really doing is timesing both sides by VBR. So if you times both sides by VB, for example, you'd end up with MB minus TV equals VB lots of M minus T all over R. And then you could times both sides by R, and you'd have R lots of MB minus TV equals VB M minus T. And then what you can do is here, you can multiply out the brackets. Now this might seem a long way of doing it, but you will isolate the M in a different way. So you'll have RMB minus RTV equals VBM minus VBT. Then get the M's on one of the sides. So I'm going to take this from both sides. So I'll have RMB minus VBM minus RTV equals minus VBT. And then I'm going to add this term here to both sides. So I'll have RMB minus VBM equals RTV minus VBT, and now look, I can factor out the m here and have RB minus VB equals RTV minus VBT, and then I can divide both sides by this expression here, and I'll be left with m equals, now what I'll do is I'll just write this quickly here, and then I'll show you another little thing to do which will impress the examiner and will give you a good step up for A-level as well. You need to think ahead. It's not just the GCSE you're thinking about, a lot of you, especially doing the higher paper. So let's have a look. Now I don't want to mess this up now. Let's have a look. Move that. Okay, let's move this here. What I'm going to do is I'm going to look at a common term here in the numerator. So we've got T and we've got V. So I'll take T, V out, and I'll have R minus B here. And then here I've got a B here and a B here, so I can take that out and have R minus V here. So that's probably the nicest way of dealing with it. This is exactly the same as this, as is this, but they all look remarkably different. And that's the joys of algebra. Depending on your initial approach will depend upon the answer. I don't agree with people who say there's just one answer for maths and that's why it's so easy. There's many different answers. There's many different ways of getting to an answer. And not all answers have the same form. So that's that question there, and let's have a look at another one now. These are not easy questions, these ones here, so you have to have your wits about you. A road is 4,530 metres long, correct the nearest 10 metres. Now, this is all under upper and lower bounds. So if you take 4,530 metres, if that's correct to the nearest 10 metres, you've got to say to yourself, what's the most it can be, what's the least it could be that would round to 4,530. Now, to cut a very long argument on this, what I say to my students is, if it's correct to the nearest 10, you just cut the 10 in half and you get 5 each way. So if you add 5 to this, you'd get 4,535, and if you took away 5, you'd get 4,525. Now, most students can see that this would round to 4,530, but I know what you're saying. You're saying, well, hold on, this doesn't. This rounds to 4,540. But if you were to choose 4,534.9 recurring, then you would convince yourself that this 4 here would not round this 3. So it would just remain at 4,530. But if you looked at 4,534.9 recurring, wherever you stop rounding your 9s, say here, this 9 here would make this a 10, and you can't fit the 10 in, so you'd carry, and you'd keep going. So 4,534.9 recurring is as good as 4,535, and that is why it is permissible to say that. So we've got here the lower bound, and here the upper bound of the road length. Kirsty drove along the road in 205 seconds to the nearest 5 seconds. So if you take, so this is in meters here, so let's write that in meters, and then we've got seconds now. So if we have 205 seconds to the nearest 5, remember what I said, split it in half, and then you add 2.5, so you get 207.5, take 2.5, 202.5, and that's your lower bound for the time taken. and this is the upper bound. And it says the average speed limit for the road is 80 kilometres per hour. Could Kirsty's average speed have been greater than this? Well, let's do some workings here. So we're going to talk here about cakes and people as an idea. So if you had 5 cakes and 4 people, they'd get 1 1/4 cakes each. But if you increase the amount of people here to 5, you'll get less cakes per people. You'll get 1 cake per person. If you increase this even more to say 10 people showing up, then it's half a cake each. So have that idea in mind, and I'll come back to that idea in a moment. So the average speed, now if you look at it here, it's in kilometres per hour. So when it says kilometres per hour, it's like percentage per 100, out of 100. That's what PER stands for, out of 100. So we want kilometres per hour. Okay, so that means we're talking about kilometres per hour as your dimensions. So we're looking for a fraction which has kilometres on top and hours underneath. So what we must first do is look at not 4,530 metres, but we know there's 1,000 metres, in a kilometre. So we know that we've got here 4.53 kilometres. And then in terms of the actual raw time here, we've got 205 seconds. And if we want to make that into an hour, well, how do we make that into an hour? This is reasonably difficult now because we want to change seconds into hours. So if we say 205 divided by 60, that'll be how many minutes? So we've got 205 divided by 60, which gives us 3.416 recurring minutes. And if we divide that by 60 again, we'd get 0.05694 recurring hours. Now, I'm going into this much detail because these kind of dimensions questions, upper and lower bounds, are very tricky. So if we just did that raw calculation there, what would that tell us? It would tell us that we had 4.53 kilometres per 0.0569, and just do a few 4s on your calculator. That would give us, and I'll write that different colour, approximately 79.6 kilometres an hour to 1 decimal place. However, we have to try and see whether her average speed could have been greater than 80. So back to the cakes and people situation now. Because if you wanted to maximise the average speed, surely you'd want to make the amount of cakes that you had be the most, and you'd want to not invite many people, especially if you were one of the guests, then you'd have more cake. So you'd want the distance to be its highest, and in this case, like so. So you'd write down 4.535 kilometres. And then in terms of the time, you'd want the people, cakes and people, you'd want the people to be less, which would mean more cake overall. So you'd want the time to be 202.5 seconds here. Now obviously when you come to do the exam you'll lay your work out slightly better than me, because don't forget I'm explaining every single step to you, hence this is not quite how it would seem if you were doing the exam. So let's change 202.5. So I think you realised from the workings previously you do 202.5 divided by 60, 3.375, and then divide that by 60 again to convert to hours, and you'd get 0.05625 hours. Now you can work that out, and if that is more than 80, then yes, it would have been true. So let's do 4.535 divided by 0.05625, and that gives me 80.62 recurring kilometers per hour, which is greater than 80 kilometers per hour, hence yes. Not only yes that I've done the question, but yes, it's true, the average speed could have been greater than 80. So quite a challenging question for 5 marks, I would say, and quite challenging for the examiner to mark. So you need to show them all the signposts. You know, they're going to give you marks if they see certain digits, like if they see digits like this, or this, and so on. This is where you start getting the marks. But lay your work out reasonably well, but understand why you're doing it, and don't just rely on that calculator too much. Okay, so that's that question done.